Okay, so connecting with the previous lecture, in this lecture I am showing you another case of procedure for testing hypothesis about mean. So in the first case, we have already conducted a Z test in which something was known to us. So what was known in the last previous case? The population standard deviation was known to us, and n was, the sample size was less than or equal to 30. But in this case, the second case indicator are when the population standard deviation or the variance is unknown, but your sample size will be equal to or greater than 30, then you need to use this type of statistic. The first step of the case is same, that if it is equal to, the mean is equal to this. Let's suppose I have 10 rupees, so mean will be equal to 10. Then the other say you not have 10 rupees. So you not have 10 rupees in your pocket, it's mean this is a two-tailed test. Another one is less than or equal to, so mean these are same. If it is less than or equal to, so this will be the opposite, it will be greater than. If it is greater than or equal to, it will be less than or equal to. Less than. So this is a left-tailed test. The level of significance as it is, but only there is the change in, because in the previous we used the population standard deviation, but now because the population standard deviation is unknown, so from the sample we will calculate the mean. So how you will calculate the mean? As you people know that, for example, if we have x, okay, let's suppose this is 1, 2, 3. So you need to calculate summation x. Summation x will be 6. Okay. Then in the next step you need to calculate the square 1, 4 and 9. It will be equal to summation x square will be 14. Then s square, which is variance, which is equal to summation x minus x bar whole square divided by n minus 1. So in the next step you need to calculate x minus x bar whole square. So you have already calculated what will be x bar. It will be summation x by n. So summation x is 6 and n is 3. So it will be 2. So in the next step what you will do? 1 minus 2, 2 minus 2 and 3 minus 2. And in the next column you need to calculate x minus x bar whole square. So when you calculate this, so your s square will be summation x minus x bar whole square divided by n minus 1. So when you take the square root of this one, you will get the standard deviation. So this is as it is, this is same, but only the population standard deviation is unknown. So at this way, from the sample, because this is sample, we have 3 scores in the sample. Our sample size is 3. So at this way you will calculate the standard deviation. N is 3 in this case, so you will put x bar, you have already calculated, x bar is 2. So 2 minus mean, let's suppose mean is 1 or 2. So you will calculate this, and at this way you will calculate. The rest is the same. So I don't want to discuss that in the further detail. I am approaching to a new case, case 3, where the population standard deviation is unknown, but sample size will be less than 30. So in such like scenario, in such like experiment, you not need to use Z statistic test. Okay, in this case we will use student t distribution. Okay, so we will use t test, which is also called student t distribution. So where you will use when the population standard deviation is unknown, just like in the previous case, we will calculate standard deviation from the sample, but you also need to have a look that what is the sample size. So if a sample size is less than 30, then definitely we will use t distribution or t statistic. This one is the same. I will discuss in the coming slides that if, for example, mean is 10, the opposite of this will be not. If it is less than equal to, alternative will be greater than. If it is greater than equal to null, the alternative will be less than. So this is left-tailed test, this is right-tailed test, and this is two-tailed test. Level of significance is same. Only the t statistic change. The t statistic will be now t distribution, because we will not use z distribution, but we will use student t distribution. And for this purpose, we will use student t table. Okay, just like for the z distribution, we use z statistic. So the formulation is x bar, which is the population mean minus the sample mean minus population mean divided by, this is the standard deviation sigma. So as you know that the population standard deviation is unknown, so this will be the sample standard deviation divided by n, which is the sample size. We will calculate the t statistic and the critical region in order to construct a critical region. So now this is a little bit changed from the z distribution. So as you know, for two-tailed test, what will be the two-tailed test scenario? If you say that I have 10 rupees in my pocket, and if I say that no, you have not 10 rupees, so I have not know that it will be less than 10 rupees or it will be greater than 10 rupees. So that is why we will use two-tailed test. We will divide the risk in two. We will divide alpha by 2 in this. So that is why we divide alpha by 2. Because now this is a t statistic, so t distribution mean is equal to 0, just like the z distribution. And in t distribution we will use a degree of freedom. So degree of freedom will be degree of freedom. Okay, so degree of freedom formula will be, we normally denote with this rho n minus 1. So the sample size minus 1. So let's suppose alpha is equal to 0.05 in this case, is equal to 0.05. So alpha by 2 will be 0.025. So now in t 0.025, and let's suppose n is 10. So degree of freedom will be 10 minus 1, let's suppose. So it will be 9. So now in the t table, in the 0.025 level of significance column, we will be looking for the value of n minus 1 for the degree of freedom 9. So then we will pick that value and we will put at this place. So because this is also symmetrical, 50% area will be lying on this side and 50% on this side. This side area is positive representation and this side area is the negative representation. So at this way we will calculate. So now I will show you, let's suppose 0.025 is the alpha by 2 value and we are looking for the degree of freedom 9. So I will show you that how you will use student t distribution table. So this is our critical value of the t distribution table. So this is also a symmetric distribution, just like the z distribution. The mean, it is a symmetric, the mean lie at 0, the mean of the t distribution is equal to 0. Because now our test is two-tailed test, so we are looking for the alpha value. So you can see this first column, just like in the z table, the first column showing the z value. In this one, the first column showing the degree of freedom. So this is the degree of freedom, okay. So you can see now we change this alpha value. So now in the example, we are looking for 0.025 because we use alpha by 2. So our level of significance one 0.05. So when you divide with 2, it will be 0.025 and we are looking for the degree of freedom 9. So this value is 2.262. Now we will write 2.26. So this is now, if I write this value, it will be 2.262. So this is plus, on this side it will be minus 2.262. This is the accepted region and behind this threshold, this is rejected region. So at this way, you will use t distribution. Similarly, if you want to check this, let's suppose our level of significance is 0.05 and the degree of freedom is 9. So now how we will find out the threshold? So I'm just going back to the t distribution table in order to find this value. So now we are looking for the 0.05. This is level of significance. Before we use 0.025, we find out the value for 0.025 against the level of degree of freedom. Now we will be find the value of 0.05 for the degree freedom 9, which is 1.833. You can see 1.833. So now we will write 1.833. This is 1.833. And similarly, if you want to find minus t 0.05 and the degree of freedom is 9, this will be minus 1.833. So at this way you will use the table in order to find out the threshold, in order to find out the accepted region and rejected region boundary. Okay, so for both two-tailed test, for one-tailed test, you will use the student t distribution in order to find out the critical values. When you find out this, then you will use this t statistic. You will find out if this value, if this calculated t statistic values lie in the accepted region, you will accept null hypothesis. If it is lying in the rejected region, you will definitely reject the null hypothesis. So in order to further clarify the meaning, in order to further clarify this concept, I am just going to solve a very simple example. Now in this question, you need to read this, you need to find out the indicator which I already mentioned to you, that when you will be able to use student t distribution, when the sample size is less than 30. So now 10 individuals. So what is the sample size? 10 individual children from a normal population. They basically picking 10 individuals. So n is what? N is 10, which is less than 30. Okay. So this way we will use t distribution. And the second indicator, the population standard deviation is unknown. When the population standard deviation is unknown and when the sample is less than 30, we will use student t distribution. So what is student t distribution? This one, test statistic x bar minus mu s divided by square root n. So now 10 individuals are chosen at random from a normal population and the height are found to be in inches: 63, 63, 66, 67, 68, 69, 70, 70, 71, 71. So these are the height of those 10 individual students. In the light of these data, discuss the suggestion that the mean height in the population is 66 inches. Now this claim is for the population. They say that the mean height of the population, the mean height of the people in that population is 66. So the average height is 66. Now we need to verify this claim, that this claim is true, this claim is accepted, or this claim is not accepted. It means this is rejected. So basically we will verify, we will clarify, we will accept this claim or we will reject this claim on the basis of what? On the basis of this sample size. So now we want to calculate mean from this sample size, because in the formulation we need standard deviation value and we also need the x bar. Okay, so I just write this 63, 63, 66, 66. I calculate, I sum this. So summation of x is 78. Now I need to calculate mean. So you know the formulation of mean, x bar is equal to summation x by n. Our n is 10 and summation s is 678. So 678 divided by 10, it will be 67.8 inches. Now I also need another parameter which is called standard deviation, because we will use this parameter in the formulation of t statistic. So how we will calculate variance? Because from the variance we will calculate standard deviation. So you know the formulation of s square is equal to summation x minus x bar whole square divided by n minus 1. Or you can also write this summation x square minus summation x whole square by n minus 1. So you know, because we have already discussed that in the descriptive portion of statistics, that how you will calculate mean, variance, covariance, standard deviation. So I don't think so it will be a huge task. So now putting these values, summation x square we have already calculated 460. So I just put this 460, 50 minus summation x 678, 678 square by 10. So you will get 45968.4 and divided by 1 minus n minus 1. So 10 minus 1 will be 9. So when you calculate, it will be, variance will be, so this is basically the variance of sample. Okay, so this is basically the variance of the sample, variance of the sample. Okay, when you take the square root of this, just like when you take the square root of this, okay, it will be cancelled with this, and you also need to take the square root on this side. So your standard deviation is 3.01. So now I am just going to start, because I have already calculated what I require. Step 1 in null hypothesis and alternative hypothesis. They claim that the mean height of the population is 66 inches. Okay. Alternative, no, the population mean is not 66 inches. Maybe it will be greater than 67 inches, or maybe it will be less than 66. So in this case, we will use two-tailed test, because when you are not sure, then you will say that it will be two-tails. Maybe it will be greater than or it will be less than. Level of significance, I want to check this experiment on the 5% level of significance, which is usually statistician, mathematician, business analyst use. The third step is t statistic. So why I am not using that statistic? Because our sample size is less than 30 and the population standard deviation is not known. So these indicators are present. So that is why I am using t statistic, x bar minus mu divided by standard deviation by square root of n. So x bar I have already calculated this one, 67.8 minus the mean is, because this is already mentioned, the population mean is 66, so minus 66, and s we have recently calculated this, s is 3.01 divided by n, so n is 10, and this is the calculated value of t. So this is basically the t value, okay, 1.89. Now we need to draw critical region. In the critical region, we need to construct a two-tailed test. Why two-tailed test? I will discuss, because we are not sure that the mean height will be 66, less than 66 or greater than 66. So we now need to calculate the boundary of critical region. This will be the rejected region, this will be the accepted region. So now the t statistic in the previous slide, I already discussed with you. If it is a two-tailed test, you need to divide level of significance with 2 and you need to find out, you need to use the t-statistic table. In t-statistic table, on the first column, they mention degree of freedom. So I already discussed with you what is degree of freedom, how you will calculate. So n minus 1, n is 10, 10 minus 1, and this is alpha by 2. So we divide 0.05 because this is my alpha. When you divide with 2, you will get 0.025. So when you find out 0.025, and we are looking for the value of degree of freedom 9. So 0.025. Now I'm just going to show you once again that how you will find out this value from the t-statistic table. So now you can see, because this is the t, the critical value of the t distribution, we looking for the 0.025 on the row. These are the alpha values. So now in this question, we are looking for 0.025 and our degree of freedom is 9. So it will be 2.262. Okay, so we will write this value 2.262. So this is plus 2.262 because this is symmetric distribution. So on this side it will be minus 2.262. So we have already concluded our critical region, which one is the accepted region, which is the rejected region. Now in the fourth step, what you need to do in the sixth step, because we already constructed critical region, now we will have a look at the calculated value 1.89. Okay, so it starts from 0. It starts from 0. Let's suppose this will be 1. Okay, so where is your value lying? Your value lying over there at 1.89. So where your value lies? It is lying in the accepted region. So when it lying in the accepting region, so what you will do? So we will accept H0 and we will reject H0. So we will accept their claim that the mean height in the population is 66 inches. We will conclude that the population mean will be 66 inches. And the other person claims that no, the population mean is not 66 inches. They are wrong. Okay, so on the basis of the sample, we accept this population. So that is why this is called inferential statistic, because we using the sample data sometime and we want to predict about the population. So at this way, we will accept a population or we will reject a population. So I hope that you understand. You also understand how you will calculate student t table, t distribution table, and how you will extract the boundaries of accepted region and rejected region. Okay, this is an example. This is an assignment. In order to further understand the concept, please try to solve this. Please use the t-statistic distribution table in order to calculate from your own side. So it will be further crystal clear. Thank you so much. Cheers. Bye.